Right now, the smartest, best-funded Fortune 500 companies on Earth are pouring hundreds of billions of dollars into artificial intelligence, and, well, 90% of them are failing spectacularly.
Yeah, and failing is almost an understatement. It's a complete operational meltdown in a lot of these places.
It's wild. Worse, almost a third of their own employees are actively sabotaging these systems from the inside.
Right, from the inside.
So welcome to the deep dive. If you're joining us today, our mission is to cut through this massive, deafening hype surrounding enterprise AI here in April 2026.
Exactly. We really need to look at the hard, unvarnished reality on the ground.
Yeah, because we are taking a massive stack of sources today. I'm talking internal reports from Deloitte, IBM, BCG, Gartner, MIT, Talix, Writer, just a dozen different industry analyses.
It's a huge stack of data.
It is, and we're using it to answer a very specific, critical question for you. How are businesses actually using AI right now? What is functionally working? And why is there such an astonishingly high rate of complete failure?
It really is the defining paradox of the current corporate landscape,
Yeah.
We're looking at a scenario where the technological capability is just unprecedented, yet the organizational capacity to absorb that technology is completely fracturing.
The current landscape, I mean, it feels exactly like the California gold rush.
Well, 100%.
Everyone is rushing out to buy pickaxes, right? Which today look like massive enterprise AI software licenses and sprawling cloud compute budgets. But very few companies are actually finding any gold.
Right, the actual return on investment, the ROI is just missing for most.
Exactly. And instead of finding gold, we're seeing companies accidentally blowing up their own minds in the process.
Yeah, through massive data leaks or internal cultural warfare.
Their shadow IT networks. It's a mess.
Which is why 2026 represents such a pivotal threshold.
Yeah.
I mean, the conversation in the boardroom has fundamentally shifted away from the wow factor.
Right. Like 2024 was defined by experimentation, wasn't it?
Yeah, 2024 was just people being amazed that a chatbot could write a sonnet or summarize a PDF.
It's like a magic trick.
Exactly. Then 2025 was the year of clunky, painful integration, trying to shoehorn those chatbots into existing workflows.
And usually failing.
Usually failing. But 2026 is the era of industrialized AI. The focus is no longer on what an AI can generate.
Okay, so what is the focus now?
The entire focus is on how it executes, specifically how it executes complex, multi-step business operations autonomously.
Autonomously. That's the key word. So whether you're a C-suite executive trying to figure out how to deploy AI without breaking your company's culture, or, a mid-level manager worried about your team's workflow.
Or just a curious professional wondering how your specific job is going to change by the end of the year.
Right. This deep dive is going to be your map of the 2026 AI workplace. We are going to go department by department, but to read that map, we have to grasp the underlying paradigm shift first.
The shift from copilots to autonomous agents.
Yes. The sources highlight this complete migration. What is the actual difference there?
Well, the distinction between those two is the mechanism of action. So a copilot is essentially a highly advanced autocomplete.
Okay.
It sits adjacent to the human worker. The human drives the process, highlights a block of text, and asks the copilot to rewrite it.
So the human is the engine, and the AI is just the accessory.
Precisely. Agentic AI flips that architecture entirely. An agent possesses the capacity to reason, to formulate a multi-step plan, and to execute that plan across various software environments without continuous human prompting.
See, I was looking at the supply chain examples in the IBM report, and the difference in capability is jarring.
It's a completely different level.
It is. An agentic platform isn't just sitting there waiting for a prompt. It actively monitors live data streams.
Right.
So let's say there is a weather disruption at a major shipping port. The AI agent detects the disruption in real time. It analyzes the downstream impact on your specific inventory.
It realizes a crucial shipment of components will be delayed by, say, 4 days.
Exactly. And on its own, this is the crazy part, on its own, it drafts communications to the affected vendors, logs into the company's enterprise resource planning system, the ERP updates the inventory forecast, and adjusts the automated reordering threshold.
And then, only at the very end of that complex chain of events, it sends a ping to a human manager.
Right. And that ping just says, I detected a port delay, I rerouted the shipment, and I updated the financials. Do you approve this logged solution?
When you break down the mechanics of what you just described, the Chief Information Officer, the CIO, is no longer simply maintaining an IT stack.
What are they doing then?
The CIO is effectively managing a massive parallel workforce of non-human labor.
Non-human labor, that is such a wild concept.
It is, but that's what it is. And that requires a complete redesign of corporate governance and control planes. The competitive advantage for an enterprise today isn't licensing the model with the highest parameter count.
Or the cleverest conversational tone.
Right. The advantage lies in possessing the most rigorous, secure ecosystem to constrain and direct those autonomous agents.
I gotta say, hearing that these agents can fully negotiate with vendors and update financial systems on their own, it makes me sweat a little.
Yeah, a lot of people feel that way.
I mean, if the AI is doing the monitoring, the reasoning, the planning, and the executing, the human sounds less like a director and more like a rubber stamp approval button.
Just clicking yes all day.
Yeah. Are we just working for the software now?
Well, the industry is attempting to solve that exact anxiety through a framework called the human-in-the-loop redesign.
Human in the loop. Okay.
The goal is to shift human capital away from granular execution and toward output auditing and strategic alignment.
So no more typing the actual email.
Right. The technical skill of prompt engineering, which was, highly sought after just 2 years ago.
Oh, yeah. People were making six figures just writing prompts.
Exactly, but that's largely obsolete now.
Mm.
The models possess enough semantic understanding to infer intent. The critical skill profile for 2026 is the AI manager.
Okay, let's ground that in reality. If I'm an AI manager on a Tuesday morning, what am I actually doing at my desk?
You are evaluating the logic pathways the agents chose.
The logic pathways.
Right. When that supply chain agent rerouted the shipment, did it inadvertently select a vendor with a poor sustainability rating, violating the company's ESG guidelines?
Ah, I see. Because the AI is just trying to fix the delay.
Exactly. The AI is ruthlessly optimizing for the parameters it was given, which is usually speed or cost. The AI manager provides the contextual nuance, the brand voice, and the ethical guardrails.
So you are setting the strategic boundary conditions, letting a swarm of specialized agents execute the 1,000 micro tasks required to fulfill that strategy.
Yes, and then conducting a forensic audit of the results before they go live.
That makes sense. It's one thing to talk about this theoretically, though. Let's look at the actual departments where this non-human labor is currently sitting today.
The back office.
Yeah, the sources categorize the immediate adoptions as the low-hanging fruit, primarily human resources, finance, and legal. Let's start with HR.
Human resources presents one of the most aggressive adoption curves in the data. The current metrics indicate 45% of all organizations have integrated AI deeply into their HR functions.
45% is huge.
And among Fortune 500 companies, that number scaled to 99%. It is effectively universal.
That's practically everyone. My initial assumption was that HR is just using it to, scan resumes faster.
A lot of people assume that.
But the functional capabilities they are deploying go way beyond keyword matching, right?
Keyword matching is rudimentary automation. That's old tech. What these agents are doing now is contextual parsing.
Contextual parsing, meaning what?
They are digesting unstructured data from a candidate's portfolio, their LinkedIn history, project repositories, and mapping that against the behavioral traits of the company's top-performing employees.
Whoa, so it's looking at what makes current employees successful and hunting for that in new people.
Exactly. And from there, the agent generates highly specific, dynamically adjusting interview questions designed to probe the candidate's precise weak points.
Wait, that is incredibly intense, and the reports highlighted a massive reduction in hiring bias, up to 50% in some deployments.
It's a huge benefit.
But I want to understand the mechanism there, because AI is trained on historical data, right? And historical data is famously biased.
Extremely biased.
So how does the AI actually reduce bias instead of just amplifying it at light speed?
It relies on a process called semantic blinding.
Semantic blinding.
Right. In traditional hiring, a human manager might unconsciously react to a candidate's name, or the specific university they attended, or the geographic location of their previous employer.
Sure, human nature.
The AI agent acts as a filtration layer. It ingests the raw resume and rewrites it into a standardized, skill-based narrative before the human hiring manager ever sees it.
Wait, really? It rewrites the resume entirely?
Yes. It mathematically strips out demographic indicators and proxy variables that trigger human bias. It forces the evaluation entirely onto objective capability metrics.
That is brilliant. It just gives you the facts of what they can do.
Furthermore, it tracks the human manager's ultimate selection rate against those blinded profiles.
To see if the manager is still being biased.
Exactly. It identifies if the manager is reintroducing bias during the face-to-face interview stage.
Man, that is fascinating. The onboarding process was another area where the depth of the AI integration stood out to me.
Oh, onboarding is totally transformed.
It's not just sending an automated welcome email with a PDF attached anymore. The AI acts as a custom integration engine.
Right.
Like it analyzes the exact skill gaps between the new hire's background and the job requirements and dynamically generates a personalized 90-day learning curriculum.
And it looks at the company's internal network graph, too.
Yes, it automatically schedules 15-minute introductory calls with the specific cross-functional colleagues that new hire will need to know. It essentially engineers the employee's social integration into the company.
It's incredible. Now, moving from HR to finance and accounting, we see a completely different set of technical mechanics at play.
Finance is a whole different beast.
Very much so.
Yeah.
Finance is an environment defined by rigid rules, structured numerical data, and regulatory precision. We observed enterprise adoption in finance spike from 37% to 58% in a single 12-month window.
That's a massive jump, and if you're a mid-sized company, the hours saved are staggering. The Pigment report mentioned finance teams saving 15 to 25 hours a week just on reconciliation tasks.
Workday reported a 40% reduction in the total budgeting cycle time.
40%. But how does dynamic financial forecasting actually differ from what a highly skilled human does in a complex Excel model?
Well, think about a static Excel model. It relies on rigid, predefined formulas. If X happens, then Y changes. A human analyst has to manually update the assumptions, say if there's a sudden spike in interest rates.
Which takes time and is prone to errors.
Exactly. An AI-driven dynamic forecasting model uses multimodal data ingestion. It isn't just looking at the company's internal CSV files.
What else is it looking at?
It is continuously scraping real-time macroeconomic indicators, global commodity prices, and even consumer sentiment from public data feeds.
So it's plugged into the entire world economy.
Yes. It uses predictive clustering to instantly generate thousands of potential financial scenarios. It's like Monte Carlo simulations on steroids. And it adjusts the company's risk profile dynamically.
Wow.
It replaces periodic manual forecasting with continuous, autonomous financial vision.
Continuous financial vision. That's a great way to phrase it. And that continuous vision is also completely upending the legal department.
Legal is seeing a massive shift.
We are seeing a complete departure from generalized AI here. Like no corporate general counsel is pasting a merger agreement into ChatGPT.
No, absolutely not. That would be a security nightmare.
Right. They are deploying highly specialized, ring-fenced AI models designed explicitly for contract review, clause extraction, and document discovery in massive litigation cases.
Deloitte provides a masterclass in this specific application. When managing thousands of legacy client contracts, they deploy specialized named entity recognition models.
Named entity recognition.
Yeah. These aren't reading the text the way a human does. They are mapping the semantic relationships within the dense legal jargon.
Okay, so it understands the legal context, not just the words.
Right. The AI can process a 200-page PDF, recognize a non-standard liability clause that deviates from the company's accepted risk threshold, flag the specific renewal dates, and convert an inert mountain of text into a relational, searchable database in seconds.
In seconds. That would take a junior lawyer weeks. And in the healthcare sector, the same parsing technology is being used for ambient AI scribes.
The ambient scribes are a game changer.
They're fascinating. It listens to the natural, messy conversation between a doctor and a patient in real time, filters out the small talk, identifies the medical terminology, and autonomously structures a compliant clinical note in the electronic health record system.
It entirely removes the administrative data entry burden from the physician.
Which is huge for doctor burnout.
Exactly, allowing them to return their focus entirely to the patient.
You know, when I look at these back office deployments, scrubbing the data in finance, parsing the contracts in legal, organizing the onboarding in HR, it reminds me of the invention of the dishwasher.
The dishwasher.
Okay, I'm listening.
Hear me out. Before the dishwasher, you'd spend an hour every night standing at the sink scrubbing plates. It was necessary, it was repetitive, and it was a massive drain on your time.
Right.
The dishwasher isn't glamorous. It doesn't cook the meal. It just fundamentally changes the amount of time you have to do actual high-value work, like planning the menu or actually enjoying the dinner.
I see where you're going. These back office AI agents are scrubbing the data so the humans can do the strategic cooking.
That's a good analogy. The time-saving aspect of the dishwasher analogy definitely holds up, but we have to push that comparison further to account for the autonomy.
Fair point.
A dishwasher only runs when you load it, add the soap, and press the button. It never notices that you're out of clean plates and decides to wash them itself.
True.
It certainly doesn't recognize that a plate is chipped and order a replacement from the manufacturer. Agentic AI does. It initiates the cleaning cycle based on environmental triggers without waiting for the human button press.
That's a critical distinction. And it's one thing to trust an autonomous agent with a static Excel spreadsheet in the finance department. If it hallucinates, you get a bad quarterly projection.
Which is bad, but fixable.
Right. But what happens when you take that exact same autonomous reasoning and apply it to a 2-ton robotic arm on a BMW assembly line or the core architecture of your company's software product?
The stakes change entirely.
Entirely. When we move out of the back office and onto the front lines of operations and IT, it gets physical.
Operations and supply chain represents the frontier where AI interacts with actual physics and thermodynamics.
Heavy industry.
Exactly. The dominant applications here are predictive maintenance and autonomous quality control. We are talking about edge computing AI systems that analyze petabytes of vibration and thermal sensor data from manufacturing machinery.
Looking for what exactly?
The goal is to predict the microscopic failure of a ball bearing weeks before the machine actually breaks down.
That's incredible. And the mechanism behind the quality control use cases is just wild. The BMW example in the sources, they are using computer vision models directly on the assembly line.
Yeah, this is a fascinating deployment.
The AI camera matrix scans thousands of points on a freshly painted vehicle in seconds. It isn't just looking for obvious dents, it is analyzing the reflection of light grids on the paint to detect microscopic scratches or panel misalignments that a human inspector dealing with eye fatigue would statistically miss.
Right, because humans get tired. AI doesn't. Foxconn deployed similar optical AI for inspecting delicate electronic components and cut their inspection times by 50%.
50%. That's a massive operational shift. But while the physical environment is challenging, the transformation in IT and software engineering is perhaps the most structurally profound shift across the entire enterprise.
Oh, absolutely. 80% of enterprise workplace applications now feature deeply embedded AI copilots.
80%.
But the bleeding edge is the rise of AI-native development platforms. The models are no longer just acting as sophisticated autocomplete for a human coder.
Right.
They are generating complete code bases, orchestrating the testing protocols, and deploying the software directly into production.
Okay, wait. If the AI is writing the code, running the security tests, and deploying the final product, what exactly is the human software engineer doing? Are they just drinking coffee and watching the terminal scroll?
Not exactly. The role of the human engineer has migrated up the abstraction stack. They're transitioning into systems architects.
Systems architect.
Right. They are rarely typing syntax in Python or Java anymore. Instead, they are designing and orchestrating multi-agent systems.
Let's break down a multi-agent system. How does that differ from just asking one really smart AI to build an app?
Relying on a single monolithic AI model to handle an entire software project often results in systemic hallucinations or massive security vulnerabilities. It loses the thread of logic over long contexts.
It just forgets what it was doing.
Exactly. A multi-agent system solves this by dividing the labor among specialized adversarial models.
Adversarial. They fight each other.
In a way, yes. The human architect sets up a coder agent whose sole directive is to write functional logic. Simultaneously, they deploy a security agent whose only directive is to relentlessly attack and find vulnerabilities in what the coder agent just wrote.
Oh, that's brilliant. They're fact-checking each other.
Yes. And finally, a documentation agent observes the interaction and writes the user manual based on the final hardened code. The human engineer's job is to design the architecture of this digital team, monitor their interactions, resolve the deadlocks when the security agent repeatedly rejects the coder agent's work, and ensure the resulting software meets the business requirements.
Spotify is doing exactly this, right? They are using machine learning models to continuously analyze the code their human and AI teams produce. And an autonomous routing system automatically pushes low-risk code changes through faster deployment pipelines, bypassing human bottlenecks.
Netflix is doing it too. They use predictive models to anticipate service degradation and autonomously reroute server traffic before the user's video even buffers.
So the human engineers are overseeing massive automated flows of logic rather than writing the logic themselves.
Which brings us to the inevitable macroeconomic consequence of this shift. If AI is taking over the drafting, the coding, the physical inspecting, and the financial forecasting, what happens to the human labor market?
Right, the job impact. Are we looking at mass substitution and those apocalyptic unemployment scenarios that dominated the headlines a few years ago?
We analyzed the Boston Consulting Group report on labor disruption, and the mechanics of the labor shift are highly nuanced. BCG estimates that roughly 50 to 55% of all U.S. jobs will be fundamentally reshaped in their daily tasks within the next 2 to 3 years.
That's half the economy.
However, they project only about 12% face absolute substitution where the role is entirely eliminated.
12% is still a massive absolute number of people, but it's not a total workforce collapse. How are they determining the dividing line? Like, why does one job get completely substituted while another is just reshaped?
BCG categorizes roles based on two primary dimensions: the expandability of demand for that specific output and the necessity of human judgment.
Expandability of demand and human judgment.
Right. Let's contrast a call center representative with a software engineer to see how this economic mechanism plays out in reality.
Walk me through the call center scenario first.
A Tier 1 call center representative faces an extremely high risk of total substitution. The work consists of highly structured, repeatable workflows: checking an account balance, explaining a return policy, issuing a standard refund.
Routine stuff.
Exactly. More importantly, the macroeconomic demand for customer complaints is capped.
Capped, meaning what?
Meaning a retail company only has a finite number of angry customers calling in per day. Once an AI agent can reliably process those tickets from start to finish without hallucinating, the company simply requires fewer human representatives.
Because the demand is fixed.
Yes. The massive efficiency gains of AI convert directly into net job losses.
Right. If your AI suddenly handles 80% of the customer calls flawlessly, you don't magically get 80% more customers calling just to chat. The volume of work is static.
Exactly. Now, observe the mechanics of the software engineering role, which BCG classifies as an amplified role.
Amplified?
Yes, the AI is taking over the routine syntax generation and standard testing. But the demand for custom software is highly elastic and incredibly expansive.
There is a massive global backlog of unmet demand.
Enterprises have thousands of internal tools, custom applications, and data integrations they have wanted for years. But they previously couldn't afford to build them because human developer time was too scarce and too expensive.
So as the AI drives the cost of producing software down, the company's appetite for new software expands to absorb the extra capacity.
Precisely. And because building complex, enterprise-grade software still requires high-level system design, strategic trade-offs, and an understanding of how the new application fits into the company's messy legacy business processes, human judgment remains indispensable.
The engineer is amplified. They are producing 10 times the output, and the market demand simply swallows that increased productivity without eliminating the job.
It's exactly like the spreadsheet analogy.
Yes. When electronic spreadsheets like VisiCalc and Excel hit the market, people genuinely believed the accounting profession was doomed. Why would you hire a room full of humans with calculators when a computer can execute the math instantly?
But spreadsheets didn't eliminate accountants.
No. They made basic arithmetic so cheap and instantaneous that it unlocked a completely new demand for complex financial modeling, scenario planning, and strategic forecasting. The sheer number of accounting and finance jobs actually exploded.
That historical parallel holds up perfectly. And understanding this dynamic of amplified productivity brings us to a major workforce trend emerging in 2026. The rise of the AI generalist.
The AI generalist. That feels counterintuitive. For decades, the entire corporate ladder was built on hyper-specialization.
Right, the witches are in the niches.
Exactly. You made yourself valuable by being the one person who knew an obscure coding language or the deep nuances of a specific regional tax law.
That was true when knowledge retrieval was difficult. But today, AI handles deep specialization flawlessly. An AI model can ingest and perfectly recall the entire global tax code or every library in a programming language.
So what's left for the human?
What AI models notoriously struggle with is context switching and broad multidisciplinary strategy. They lack common sense across domains. Therefore, forward-thinking enterprises are actively recruiting AI generalists. These are professionals with a broad, systemic understanding of the business who can oversee, connect, and translate the outputs of diverse AI agents across multiple departments.
They are the conductors of the orchestra, synthesizing the specialized outputs into cohesive business strategy.
Exactly.
That is a vital piece of operational advice for anyone listening. Do not try to out-specialize the machine at a granular task. Your value is in managing the machine across different
It's the
fields.
only way to stay relevant.
So we've mapped out what the AI is doing, how it's parsing the data, and how it's reshaping the labor economics. But let's look under the hood at the technical infrastructure.
The physical constraints.
Right. How are companies physically affording and securing this massive compute shift? Because running giant AI models for every single employee's microtasks sounds like an astronomical cloud computing bill, not to mention a terrifying data security risk.
You've identified the exact physical and financial constraints that forced the enterprise tech landscape to pivot sharply in 2026.
What changed?
The era of relying exclusively on massive generalized foundation models, those enormous systems trained on the entire internet, is essentially ending for daily enterprise operations.
Oh, really?
Yes. The industry has aggressively shifted toward domain-specific language models, or DSLMs.
DSLMs. How does the architecture of a DSLM differ from the massive cloud models we've all been using?
Well, massive foundation models require staggering amounts of compute because they possess universal knowledge. They can write code, they understand quantum physics, they know 16th century literature.
Right. They know everything.
But from a corporate procurement perspective,
Yeah.
why would you pay the exorbitant inference costs to query an AI that knows Shakespeare when your company only needs it to understand maritime shipping regulations or pharmaceutical compliance?
You're paying the salary of a universal polymath when all you actually need is a highly focused paralegal.
Exactly. And the polymath is expensive to run. DSLMs are significantly smaller open-weight models, typically ranging from 7 billion to 13 billion parameters.
Okay, so much smaller.
Platforms like Mistral AI's Forge allow companies to take these smaller, highly efficient models and train them exclusively on the company's own proprietary data corpus.
Just their own data.
Because the parameter count is drastically lower, they require a fraction of the compute power. They respond with ultra-low latency. And most importantly, because they are small enough to be hosted internally, the company's proprietary data never leaves the corporate firewall.
That structural shift ties directly into another major trend in the sources, hybrid AI compute and the zero-trust edge.
Yes, the edge.
I always assumed the endgame of AI was just massive server farms in the desert doing all the thinking, while our devices just acted as dumb screens. Are you saying the processing is moving back to the local hardware?
It has to. The sheer physics and economics demand it. If you have an autonomous agent constantly monitoring your screen, reading every email draft and analyzing every spreadsheet to assist you, streaming that continuous high-bandwidth data to the cloud and back creates immense latency.
It would lag like crazy.
It would. Furthermore, it's financially ruinous. And sending unencrypted PII, personally identifiable information, to a third-party cloud violates almost every modern data privacy regulation.
So how do they fix it?
The solution is the local-first routing approach, powered by neural processing units, or NPUs, built directly into the silicon of modern laptops and smartphones.
Think of this routing algorithm like a computational triage nurse sitting right on your laptop's motherboard.
I like that analogy.
When you ask your AI to do something, this tiny, ultra-fast router evaluates the request. If it sees you are just asking to summarize a local PDF or draft a standard email, it flags the task as low compute.
Right.
It routes it to the small 7 billion parameter model running entirely on your laptop's NPU. It processes instantly with zero cloud computing cost, and the data never leaves your physical machine.
But if the triage router detects a highly complex, multi-step logic puzzle that exceeds the local model's capacity, it dynamically establishes a secure, encrypted tunnel to the massive cloud models, executes the heavy reasoning, and pulls the result back down.
This hybrid architecture mitigates the security risks while optimizing the financial spend.
It also directly addresses the critical constraint of power consumption: green AI.
Green AI. The reports emphasize that data center power consumption has moved from an environmental concern to a hard operational bottleneck.
Energy grids literally cannot support the power demands of running universal cloud models for every corporate task. Running smaller models locally distributes the thermal load and energy consumption, making energy intelligence a mandatory component of IT architecture.
So we have mapped out a landscape of incredible sophistication. We have dynamic forecasting, multi-agent coding systems, semantic bias blinding, and hyper-efficient edge computing. The technological foundation is remarkably robust.
It is.
But And this is the massive glaring butt of this entire deep dive.
Here we go.
If you're listening to this and looking at your own company's shared Google Drive right now, you are probably realizing a harsh truth. Despite these incredible technological capabilities, the data shows a devastatingly dark reality on the ground.
The vast majority of companies are failing miserably at actually making this work.
The statistics are undeniably grim. Independent research from the RAND Corporation, BCG, and S&P Global tracks the failure rate for enterprise AI implementations at somewhere between 70 and 90%.
Let that sink in. Up to 90% of these massive, highly publicized corporate AI initiatives are crashing into the dirt.
The S&P Global data found that 74% of companies report achieving absolutely no tangible value from their AI investments. No cost savings, no revenue bumps, no efficiency gains.
And by mid-2025, 42% of organizations had simply given up, actively abandoning most of their generative AI initiatives entirely.
If the underlying technology is as capable as we just discussed, why is the operational failure rate so catastrophic? What is going wrong?
The foundational technical reason is data chaos.
Data chaos.
An artificial intelligence model is at its core a reflection of its training data. It has no independent understanding of a company's business model.
It only knows what you feed it.
Exactly. If an enterprise's data is deeply siloed, locked away in ancient ERP systems, fragmented across thousands of unformatted Excel spreadsheets, buried in isolated CRMs, and hidden inside scanned PDFs, the AI cannot map the relationships.
It just sees noise.
When you feed an agentic system chaotic, contradictory, unstructured data, it doesn't just fail gracefully. It hallucinates with absolute confidence, its automated workflows shatter, and it transitions from a productivity tool into an active operational liability.
It's the classic garbage in, garbage out principle, but happening autonomously at light speed. Data chaos isn't just an annoyance for the IT department anymore. It is the literal reason your million-dollar chatbot keeps hallucinating incorrect inventory numbers.
To fully understand this failure mode, MIT and industry researchers have codified the 10-20-70 rule of successful AI deployment.
10-20-70, break that down.
The rule states that the ultimate success of an AI project relies 10% on the algorithms themselves, 20% on the technology and data infrastructure, and an overwhelming 70% on people and processes.
Wait, 70% of the effort needs to go into human workflows for a software project.
Because AI isn't just a software upgrade like moving from Windows 10 to Windows 11. It is a fundamental redesign of how the corporation extracts value from labor.
Oh, that makes sense.
But the vast majority of failing organizations suffer from a severe technology-first mentality. They invert the rule entirely.
They focus on the 10%.
They spend 70% of their budget and executive attention buying a shiny, highly hyped AI tool, assuming the technology itself is the strategy. They spend almost no time defining the granular operational problem they are trying to solve, or cleaning their data, or redesigning the workflow for the humans who will actually use the system.
It's like buying a ridiculously expensive high-tech treadmill.
The treadmill analogy.
The treadmill is your 10% algorithm. You spend a fortune on the best model available. Then you stick it in a cluttered, unheated garage where half the outlets don't work. That's your 20% data infrastructure.
Right.
And then you absolutely refuse to change your diet or actually wake up early to run on it. That's the 70% people and processes. You spent the money, you have the technology, but you aren't getting fit. Instead of looking at your habits, you blame the treadmill.
That behavior is exactly what leads to what the industry calls the pilot trap.
The pilot trap.
An organization will build a proof-of-concept AI in a pristine, isolated sandbox environment with perfectly formatted dummy data. It works flawlessly. The executives applaud the demonstration.
But
the moment they try to deploy it into production, where it collides with the messy reality of legacy systems and actual human behavior, it immediately breaks. It simply cannot scale out of the sandbox.
But the failure isn't just about messy data and bad executive planning. When I read the Writer 2026 survey, conducted alongside Workplace Intelligence, my jaw hit the floor.
The cultural crisis.
Yes. The biggest barrier to enterprise AI in 2026 is psychological. The implementations aren't just failing under their own weight. In many cases, they are actively being attacked from the inside by the company's own workforce.
We are witnessing a profound cultural crisis. The survey data interviewed thousands of executives and employees, revealing a massive chasm of trust.
It's bad.
75% of executives admitted in anonymous surveys that their company's AI strategy is largely performative. It's designed more to signal innovation to the board of directors and Wall Street analysts than to provide actual functional guidance to the workers.
Performative strategy. They are deploying tools they don't understand just to pump the stock price. And the employees aren't stupid. They can sense that the deployment is hollow.
That performative push creates acute anxiety. 64% of CEOs express fear of losing their jobs over a botched or delayed AI transition.
They panic.
To force adoption, 60% of companies reported plans to lay off employees who refuse to adapt to the new AI tools, while simultaneously elevating a small cohort of highly productive AI superusers.
This dynamic immediately creates a hostile, two-tiered workplace environment.
And the reaction from the workforce is literal sabotage.
The statistic that absolutely floored me, 29% of employees openly admit to actively sabotaging their company's AI strategy. And when you isolate Gen Z workers, that number skyrockets to 44%.
Almost half of the youngest cohort in the workforce is actively fighting the technology.
Almost half.
Organizational psychologists define this as the trust and resistance cycle. When executive leadership pushes AI deployment purely as a blunt instrument for cost-cutting, explicitly threatening layoffs without offering deep retraining or workflow redesign, the employees naturally view the AI not as an assistive tool, but as an existential predator.
Right. Sabotage becomes a mechanism of self-preservation.
Exactly. Dropping a massive AI system into a rigid corporate culture without preparation is exactly like an organ transplant. The corporate immune system, the employees, will view the AI as a foreign, invasive threat and actively attack it. Employee sabotage is literal tissue rejection.
How does the sabotage actually manifest technically? Like, are they smashing servers?
It's much more insidious than that. It takes the form of passive-aggressive noncompliance. Employees will quietly refuse to use the authorized tools, reverting to manual processes while claiming the AI is broken.
Wow.
More destructively, they will intentionally input ambiguous or garbage data into the system to degrade the model's accuracy, effectively proving their point that the machine is unreliable. Or they will maliciously slow-roll implementation projects in endless committee meetings.
It is a corporate civil war, and while this active sabotage is happening to the official tools, you also have the parallel nightmare of shadow AI.
Yes. The workforce is highly polarized. While one faction sabotages the authorized AI, another faction is bypassing IT entirely to use unauthorized public AI tools because they desperately need the efficiency gains.
Shadow AI.
67% of executives believe their company has already suffered a data leak or security breach directly caused by employees pasting proprietary source code, confidential client data, or internal financial numbers into public chatbots just to get their work done faster.
So the IT department is fighting a two-front war. The official secure tools are being sabotaged and rejected, while the unofficial insecure tools are constantly leaking company secrets.
It's a nightmare for the CIO.
How do the 5% of companies that are actually succeeding avoid this absolute nightmare? What is the immunosuppressant therapy required so the corporate body actually accepts the new organ? How do you stop your 23-year-old marketing hire from sabotaging a $1 million deployment?
The successful minority approach the deployment through a framework known as capability transfer.
Capability transfer.
If we examine the Talix model highlighted in the source materials, it demonstrates that successful enterprises do not rely on eternal dependencies with outside consultancies. They don't hire a tech firm to build a mysterious black box AI and suddenly drop it onto the employees' desks on a Monday morning.
Because then the employees feel like they're being managed by an alien technology imposed from above.
Exactly. Capability transfer treats AI adoption primarily as a deep, human-centric change management program.
Meaning they talk to the humans first.
Yes. These companies transparently upskill their workers before the technology is even deployed. They intentionally redesign the job roles, explicitly targeting the elimination of the most boring, repetitive tasks that the employees already hate.
That's smart. Give them a quick win.
Most importantly, they ensure that the human workers truly own the design of the AI workflows.
They give the employees agency over the agents.
Precisely. When an employee feels that they are directing the AI to make their own workflow easier and more impactful, rather than feeling like the AI is quietly measuring them for a replacement, the resistance evaporates. Capability transfer means building permanent organizational intelligence, not just renting a software license.
To wrap this all up, we need to synthesize what this immense paradigm shift means for you, the listener, right now, today, in your own career and your own company.
The through line of everything we've analyzed today is that AI has definitively left the chat window. We are operating in the era of autonomous agents.
It's not just a chatbot anymore.
No. This technology is aggressively revolutionizing the back-office functions of HR, finance, and legal through semantic parsing and dynamic forecasting. It is redefining physical operations and IT architecture through edge computing and multi-agent systems.
But this incredible theoretical potential is currently crashing headfirst into a massive wall of chaotic data infrastructure and intense human psychological resistance.
Right. If you want your company or your personal career to be in that 5% that actually finds gold in this rush, you have to stop chasing the performative hype.
Stop buying the shiny pickaxes just to signal innovation.
The winners in 2026 aren't the companies with the biggest, most expensive language models. The winners are the ones with pristine, rigorously organized data hygiene.
They have specific, narrowly defined operational problems they're trying to solve.
And most critically, they have built a workforce culture that feels empowered by the technology, not hunted by it. The most valuable professional of this decade is the AI generalist, the systems architect who understands the broad business logic and can manage these digital workers across multiple domains.
Treat AI as an operational teammate that requires clear management and ethical guardrails, not as a magic wand that solves organizational dysfunction on its own.
The technology is merely an amplifier. It will amplify your efficiencies, but it will also ruthlessly amplify your existing organizational chaos.
I want to leave you with a final thought to mull over as you head back to work. We have spent this entire deep dive analyzing how humans interact with AI inside the walls of a single company.
How we manage it, how we secure it, how we resist it.
Exactly. But as agentic AI takes over supply chains, procurement, and contract drafting across the entire economy, we are rapidly approaching a moment that the sources only briefly hinted at.
It's the next frontier.
Very soon, your company's autonomous AI will spend the majority of its time negotiating, arguing, and making binding financial deals directly with your competitor's AI with absolutely no humans in the loop. The pickaxes are going to start trading with each other at light speed.
That's a wild thought.
When two autonomous, hyper-intelligent corporate AIs disagree on the liability clauses in a multi-million-dollar contract, who blinks first? Thanks for joining us. We'll catch you on the next Deep Dive.